Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our right rectangle by file, which is another function in our numerical demo series. And particularly, we're focusing in on numerical integration for this set of examples. This video assumes that you have already watched the video that set up the project as well as triaging the switches in your main and the video that focused on the left rectangle by file. In this video, we're just going to look at the differences in the left rectangle by file and then apply some changes to be able to figure out how to do our right rectangle by file, mid rectangle by file, and trapezoidal by file. First, we're going to focus on our right rectangle by file. I'm also going to assume that you have two input files, your input_01.csv as well as the input_02.csv. Whether you got them from me or you generated them yourselves doesn't really matter. Essentially, all you need is a two-column comma-separated values file where the first column represents the X values and the second column represents the Y values. So what we're going to do now is we're going to jump first to our left rectangle by file. And essentially what we're going to do is very carefully make a copy of everything inside the function. And we're going to go to our right rectangle by file, and we're going to overwrite everything that was there. Now, everywhere we have a left in either a comment or in a printf, as well as a file name, we want to change from left to right. Now, after doing a few basic changes like this, let's take a look at what really differentiates the two. And the answer is not much. Effectively, we are still going to calculate the X delta as the difference between the X right and the X left. And as I mentioned in an earlier video, we're making the assumption that the X right is greater than the X left. This is something we would want to address in a future video. Now, the main difference between the two approaches is merely that you would use the Y right instead of the Y left to calculate the area. And if you go back to your Excel again for just a second and you look at the graph, essentially what is happening and what is different is that we are simply using now this second data point to calculate the area that would otherwise be formed underneath these data points. So what changes do we have to make? Well, as I mentioned, not really a whole lot. Instead of using the X left for your height, you simply want to use the, excuse me, let me rephrase that. Instead of using the Y left as your height, you want to use your Y right as your height. And because we spent as much time as we did with setting up our example earlier, there are effectively no additional changes that need to be made. At this point, what we can do is go ahead and build our executable. We can come out to the command line. And if you notice, keep in your mind that we ran this with the file previously for the left-hand side. So keep this value in mind, the 0.671650. And then what we want to do is run our right rectangle option on the same file. We should once again read in the same data. And you'll notice that we actually get a different result. And in this case, because of the shape of our data, it is actually going to be slightly less than the X left. Essentially, if you notice that the first derivative, if you would, of that function is going to be negative, in other words, it is decreasing, then you would expect the right rectangle to actually result in a smaller value for the area. So in other words, 0.661650 as compared to 0.671650. Now, granted you, it's not a significant difference between the two, but we only have a finite amount of data. We only have 101 pieces of data. And we also want to take a look at the output file to verify that it is correct and that we do not have any more typos. So we'll take a look at our rightrectangle.csv, and you'll notice that once again, you actually have n-1 rows, or in this case, 100 sections or segments. All right, so at this point, what we want to do is we want to take a look now at the other two functions, the midrectanglebyfile as well as the trapezoidalbyfile. Before we do that, I'd like to take just a second to look back at the Wikipedia article and once again remind ourselves of how the trapezoidal rule should work. The trapezoidal rule essentially averages the heights for the two data points. So for your x left and your x right, we would essentially add those two together, divide by 2, and multiply that by the width of the rectangle. So what we want to do is we want to go ahead and jump ahead now. We're going to do the trapezoidal rule first, and we're going to come back to the mid rectangle. To begin with, what I'd like to do is I'd like to once again borrow my code from the earlier examples. So I'm going to copy my right rectangle code, and I'm going to paste it now into my trapezoidal by file. Everywhere I have a reference to right rectangle, I simply want to replace it with trapezoidal. And also in the output file. So in this case, trapezoidal. Now, the thing that we want to look at is how are we actually calculating the area current? And the difference being is that we are not just looking at a y right or a y left for the height. Instead, what we're going to do is we're going to look at y left plus y right, and we're going to get the average of the two. At this point, then we could either create a temporary variable or simply modify our formula for our area current. And once again, we're reaping the benefits of correctly setting up this first function. And as a result, these are not terribly different. And so in this case, all we need to do, I'm going to use an extra set of parentheses. I'm actually going to multiply my 0.5 times my y left plus my y right. And the only thing to notice then is if you go back to the Wikipedia article, that essentially our b minus a that is mentioned in both the rectangle rule and the trapezoidal rule are essentially my x right minus my x left. All right, so if we don't have any other things to check here, perhaps a minor detail here. How about if we say that we would like to set up the next trapezoid, just for consistency's sake? I believe we have everything that we need here. At this point, let's go ahead once again and build it. And then we'll go ahead and run this, now not with the trapezoidal, excuse me, with the right rectangle, but rather with the trapezoidal. And once again, you see the input file or the data read in from the input file, as well as the area associated with that calculation. And in this case, you'll notice that it fell somewhere in between our 0.661 and our 0.671. All right, so that leaves us with just one more function to go. And in the midrectanglebyfile, we're actually going to do this slightly different. There's going to be a little more calculation involved. The net result is that the midrectanglebyfile is actually going to look very similar to the trapezoidalbyfile. However, what we're going to do is we're going to set this up for future examples in which we can actually weight a particular data point heavier than another. And so the first thing that we want to do is go ahead and make a copy once again of either the left or the right rectanglebyfile. But then what we're going to do is we're going to add some additional variables. So we're going to go ahead and copy, and we're going to go ahead and paste it. And let's go ahead and make our changes in our documentation first. So everywhere you see right, go ahead and change it over to mid. But then what we want to do is we want to focus in on the fact that this is going to be a little bit different. So to help make sense of the differences, we're going to go ahead and add a couple of additional variables here. And once again, some of these are just simply out of convenience for us to understand the problem. So one of which is going to be the slope, is we're going to calculate the slope between two of our adjacent values to be able to determine or interpolate what the x mid and y mid should be. Now, in addition to this, we want to go ahead and create a temporary variable, or we're going to consider it a temp variable of x mid that's also a double, and then a double y mid. You could once again consider them temp variables or convenience variables. Now, what I want to do here is I'm going to maintain some of this. I'm going to delete some of our comments real quick. And essentially what we're going to do is we're going to leverage that the slope, or m, is simply going to be equal to our y delta divided by our x delta. And just a reminder then, our y delta is essentially going to be equal to our y right minus our y left, and our x delta is going to be equal to our x right minus our x left. Now, that second statement we already knew because we had already calculated. That first statement we had not yet ran into. So let's go ahead and convert that one into code as well. So we have our y delta is equal to y right minus our y left. And I believe we probably should go ahead and create one more temporary variable. And once again, this one is also essentially just a convenience variable. So we have double of our y delta. Now, at this point, since we have both our y delta and our x delta, we can easily go ahead and calculate the slope as simply y delta divided by x delta. Now, that doesn't really get us anything because that's all information we already knew. Instead, what we want to do is we want to figure out how do we calculate our y mid using our x mid. Well, first thing, let's go ahead and describe what our x mid really is. So our x mid is going to be some data that lies in between or linear interpolated between our x left and our x right. Now, for this example, we're going to go ahead and assign it at the midpoint, or 0.5 times x delta. But the point and the reason why I wanted to go through this example differently is to emphasize that that 0.5 is not necessarily consistent. In other words, you could technically bias it to one side or the other. And so if anything, you're going to see when you look at further numerical methods that there are methods that allow for you to pick different locations within an interval, and as a result, create higher order approximations. But for this example, what we want to do is we want to leverage our x left, and we simply want to add to it 0.5 times our x delta. Now, rearranging the slope equation, what this does is this allows for us to calculate our y mid. And once again, our y mid is somewhat of an approximation of our data points. In other words, it's a linear interpolation, but it is based off of the slope of existing data points, or the difference between existing data points. Once again, we're going to use then the essentially the slope formula, and rearranging it, you'll get the y mid is just simply equal to the slope times then the value of our x mid minus our x left. And then if you want to go ahead and put an extra set of parentheses around this, that's fine. And then you simply shift it up, or you add to it the value for y left. In other words, we're essentially using the x left and the y left in conjunction with the slope to determine what the y mid is going to be. At this point, then our area current is going to be our x delta times our y mid. Now, if we've got this correct, we should see only a minor difference between this calculation and the one for the trapezoidal rule, but that is mainly because of the fact that we've chosen to use the 0.5 value, or in other words, we've emphasized the midpoint, not necessarily that it fell somewhere on the interval. The only other change that we need to make is in accordance with our instructions. And if you look at the mid rectangle, or rather the output file, you'll notice that we have been requested to also put in this x mid data. And so what we do here is we simply add one more %f to our string and sandwich in between our x left and our x right an additional value or variable of x mid. Now, assuming that we have all of our calculations right and we don't have any parentheses off, we should be able to compile this, and let's go ahead and run it. And what we'll do is we'll swap out our trapezoidal rule now with a mid rectangle, and we'll run it, and you see once again we get 0.666650. And drum roll, sure enough, it's the same value for the other one. So it looks like we've got our mid and our trapezoidal functions correctly written, as well as our right rectangle. So once again, hope that you found this video useful. As always, if you have any questions or comments, do not hesitate to email me, and thank you for watching.